Subject: Physics. Topic: Electrolysis. Passing an electric current through a liquid is called electrolysis. We are going to look carefully at what happens with two liquids, water and copper sulfate, but first the general ideas. The electric current enters the liquid at the positive plate, called the anode, and leaves it at the negative plate, called the cathode. In liquids the current is carried by ions. Ions are charged particles, atoms or groups of atoms. Ions can either be positive or negative, the positive ions being attracted to the negative plate and the negative ions to the positive plate. A positive ion is a particle with some negative charge taken away, and a negative ion is a particle with some extra negative charge added. Some liquids conduct electricity. These contain ions and some do not. These do not contain ions. Some conduct well, they have many ions per cubic meter, others do not. They have fewer ions per cubic meter. The following list separates some common liquids into conductors and non-conductors. Preferential discharge of ions. A source of direct current is connected to a pair of inert electrodes immersed in molten sodium chloride. Because the salt has been heated until it melts, the sodium ion flow toward the negative electrode, and the chlorine ion flow toward the positive electrode. Chlorine ions that collide with the positive electrode are oxidized to chlorine gas, which bubbles off at this electrode. The net effect of passing an electric current through the molten salt in this cell is to decompose sodium chloride into its elements, sodium metal and chlorine gas. Faraday's first law of electrolysis. The mass of the substance liberated or deposited on an electrode during electrolysis is directly proportional to the quantity of electric charge passed through the electrolyte. If m is the mass of a substance liberated or deposited at an electrode due to the passage of charge q, then according to Faraday's law of electrolysis, m inversely proportional to q, or m, equals zq, where z is a constant of proportionality and is called electrochemical equivalent of the substance. It has the same charge which passes due to a steady current I flowing for time t, then above equation can be written as m equals z times I times t equals z times q. If q equals 1c, then m equals z. Hence electrochemical equivalent of a substance is the mass of the substance liberated or deposited in electrolysis by the passage of 1 coulomb of charge. Faraday's second law of electrolysis: if the same quantity of electricity, electric charge, is passed through different electrolytes, the mass of an substance liberated or deposited altered at an electrode is directly proportional to their chemical equivalents. M, inversely proportional to E. M1 over M2 equals E1 over E2. Here M1 and M2 are the masses of the substances liberated or deposited, and E1 and E2 are their respective chemical equivalents. Uses of electrolysis. 1. Electroplating. This means coating one metal with another by electrolysis, example, silver plating of cutlery, chromium plating of car bumpers, kettles and taps. Iron is zinc plated for use as corrugated sheeting or nails. 2. extraction and purification of some metals. Copper is refined by electrolysis and aluminium is extracted from its ore by this method. Thank you.